I'm Wan Li. We open new chapter 5, test hypothesis. We already studied estimation. Estimation and test hypothesis are very much related. Of course, estimation is essential prerequisite for test hypothesis. After studying estimation and test hypothesis, we'll go to the statistical analysis method, categorical data analysis, ANOVA, analysis of variance, and regression analysis. So just keep in mind what is going on test hypothesis. Okay, let's go. Today's topic is null hypothesis and alternative hypothesis. What are they? The term hypothesis is familiar in everyday life as the term estimation. Literally, a hypothesis involves proposing a certain assertion and then evaluating whether this hypothesis is true. In statistics, hypothesis testing refers to the process of determining whether certain assertion, description, and statements about the parameters of a population are valid. Okay, certain assertion, description, and or statement are valid or not. When forming a hypothesis about a population parameter, two hypotheses are typically set: null hypothesis and alternative hypothesis. First, alternative hypothesis is formulated as the contents of the new assertion, subject of interest, or information that differs from previously known content. Okay, that kind of a thing, that kind of a statement, description, formulate alternative hypothesis. The null hypothesis, on the other hand, is generally formulated to be contrary to the contents of the alternative hypothesis, a rebirth statement. For example, in courtroom trial involving a suspect A, suspect A, alternative hypothesis would be A is guilty in courtroom, while the null hypothesis would be A is not guilty. Understand that? Why? Presumption of innocence, okay? That is in laws. Null hypothesis denoted as H0. Alternative hypothesis denoted H1, okay? So it is like a symbol. Let's see some examples. When there is a bent coin, biased coin, tilted coin, and we want to test the hypothesis, the probability of landing on heads and tails are not same. Why? That coin is bent, okay, biased. That's why we want to test the hypothesis. Probability on head and tail are not the same. The null hypothesis, alternative hypothesis are as follows. Alternative hypothesis, P of H is not equal to P of tail, T, tail, head. The other one, H0, null hypothesis, is we usually know, okay, where is it? Previously know the coin probability of head and the probability of a tail are equal. That is, we know that kind of thing. So that is in H0, null hypothesis. In the case where there is a claim that the waiting time at a certain service counter exceeds an average of 5 minutes, there is a claim. The claim is assertion, right? So exceed 5 minutes is H1. You better think about H1, alternative hypothesis. What is your claim, assertion, description? What do you want to prove? Not prove, but empirically prove. Mu greater than 5, the waiting time at a certain service counter, because the window, one window is closed, So that kind of claim is natural. What is H0 in this case? Mu, the reverse of this one is mu less than or equal to 5. Okay? What is the difference? Here, one way, two way in this example, two sides. This one is just one side, mu greater than 5. So one side, what? Okay? One side test the problem. For the hypothesis testing and the claim that lifespan of a certain electronic product is less than 2,000 hours. The lifetime of that electronic product lifetime is known as 2,000, but now they reduce the cost of production, okay, product cost. So lifetime may be less than 2,000, reduced, okay? That is a natural claim. That is what? H1. We want to test whether mu less than 2,000 or not, mu greater than or equal to 2,000. You understand this simple example, H0 and H1? You have to set up your H0 and H1 exactly, okay? For same argument, this kind of argument, some persons say H0 is mu greater than or equal to 5, H1 mu less than 5, something like that. It's wrong. You should not set up this way, okay? This is wrong. Everybody has same hypothesis. Note, the hypothesis expressed above, the equality sign is included only in null hypothesis. It is important. Since hypothesis testing is conducted under the assumption that the null hypothesis is correct. Okay? Okay, accept null hypothesis is correct. Then we start to test hypothesis. That means that's why equality sign is in what? H0. Okay? So hypothesis, two kinds of hypothesis, okay, should be set up first. Okay, that's it today. Thank you. Bye.